right, so this is number 4 on page 263. So I kind of sketched up the picture that they have, and they give us um, areas A and B, and these both go to infinity in both directions. So I just, to color them in, I had to stop at some point. So part A says, show that the shaded area A is infinite. So I know a lot of you were showing that the area wasn't stopping or having an exact value, and that's the point. The area keeps growing, and here's why. All right, so if we find the area underneath this curve, so we're going to say the integral from 1 to infinity of x to the negative 2/3 dx, we end up getting an integral of 3x to the 1/3 from 1 to infinity. Well, here's the difference that that you should notice. When we were doing the infinite integrals before, our exponent was actually negative in every single example, which gave us a finite value. Okay? Since our exponent is positive, what this means is the bigger x is, the bigger the value times 3 we're going to get. So what that essentially means is our area keeps growing. It's going to be infinite. And all you need to do is plug in two really large numbers for x, or two, yeah, like 1,000 to maybe 10,000 or bigger if you want, and just show that, wow, it's not becoming static like our prior examples, it's getting bigger and bigger. Therefore, the area is infinite for A. Alright? Alright, so, and again, the result of that is because this is a positive exponent rather than a negative like we did in the prior chapter. Alright, B says, find the shaded area of B. So basically, we're going, instead of from 1 to infinity for x, we're going from 0 to 1 using the same function. So we're going to integrate again, and we get the same integral. Oops, 3x to the positive 1/3. Okay. But this time we have a finite range, so we end up with 3 minus 0, because I'm putting 3 in for x, 3 to the 1, or sorry, 1 to the 1/3 is 1 times 3 is 3, 0 to the 1/3 is 0. So we end up with a value of 3 for our area. Alright, so this is part C. So part C says that we are supposed to find the area for A rotated through 360 degrees about the x-axis. Sorry, not the area. They want us to find the volume. Okay, so here is A. So we're basically taking this A and rotating it 360 degrees, or a complete circle. So we're not interested in B. So we're interested in going from A to infinity. So what we're going to do is we're going to integrate. So I'm going to pull pi out front. We're going from 1 to positive infinity using the equation x to the negative 2/3. And remember, since we're finding area, we now have to square what y equals. So y equals x to the negative 2/3, and now we have to square y. So if I square y, I have to square this, and then times dx. Okay, so I'm going to go ahead and rewrite this in a simplified form. So from 1 to infinity, we end up with x to the negative 4/3 dx. Okay, now I'm going to integrate. So I end up with pi times, so remember, we're going to be adding 1, or in this case 3 over 3, because that's the same thing as 1. So I end up with x to the negative 1/3, which means that I divide x by negative 1/3. When I do that, that's the same thing as negative 3. Okay, x to the negative 1/3, that's the integral. And then we're going from 1 to infinity. So I'm going to pick a really large number to put in for x, like 1,000,000 or 10,000,000 or 100,000,000. Okay, the bigger the better. Okay. Okay, so that's the infinite part, because I want to get as big as possible. And now from that, do this, I'm going to deduct out when I put in 1. Okay, so basically I'm just going to pop this into my calculator, and what I end up getting is approximately 3. Okay, because this yields a really small value, and it's a negative value because of the negative here, and then I'm adding, right? Negative times negative is positive to 3. So it's so small that we don't actually see a change. So we end up with a volume of 3 pi for that area that goes on from 1 to infinity. Alright, so let's do D now. So D is the same idea, except that we're looking at area B. So if you'll recall, area B is this part that goes to infinity. So from from 1 on the y-axis to infinity. And we're going to be rotating part B about the y-axis. So let's go ahead and do that. So we're going to set this up the same way. So we say pi, and then our bounds are 1 on the y-axis to infinity. Okay, here's the catch though. My current equation is this, right? So what we need to do is we need to get this solved in terms of y. So that means we need to get x or x squared on its own side, because what we're going to end up having to do is substitute in x squared here and then integrate with that. So I'm just going to solve for x squared, and then I can just do straight substitution. So basically the way I'm going to do that is I'm going to raise both sides of my equation to negative, and I'm doing a negative because I need it to be positive x squared, to negative 3, right? Because negative 2/3 times negative 3 is positive 2. So that'll be my exponent on x. When I do that, I get y to the negative third equals x to the positive 2. So that tells me that everywhere I see x squared here, I'm going to plug in y to the negative third. So let's go ahead and do that. So we end up from 1 to infinity plugging in y to the negative third dy. And now we can, looks like there's still stuff on the screen. Okay, so now we can integrate. So I end up with pi times, okay, remember when we integrate we add 1. So that tells me I'm going to have y to the negative 2, which means that I've divided by negative 2. Right? So that becomes negative half, right? If I want to write that, or y to the negative 2 divided by 2, it's the same thing. Okay, and that's all happening from 1 to positive infinity. So now I'm just going to go ahead and plug in a really large value like I did on the previous section, so like 100 million if I want. Okay, so negative half times 100 million. The bigger the better because it gives us the most accurate response. And then from that I'm going to subtract negative half, and then I put in 1 for y. Okay, so that's our lower bound. Okay. Alright, so if we go ahead and put this in our calculator, we end up getting negative 0.5 times 100 million to the negative 2 power minus negative 0.5, which is positive 0.5, and I end up getting pi times 0.5, which means that my volume is half pi, or 0.5 pi. So that is how you do 4D. Alright, so that is all for number 4.